Welcome to the Million Vegan Grandmothers podcast. And I am so thrilled to have Jerry Pollack here, an amazing scientist, Dr. Jerry. Oh, thank you for being here. When I started looking at Jerry's work, I had recently read, when I was writing a book about hydration, his book, The Fourth Phase of Water. Super interested in structured water, how that absorbs differently into our matrix, into our cells as humans for health. And I was able to interview Gina Bria when I was in San Francisco, and she said, Jerry's your man. So I also have a guest interviewer, Paul Papin, and together we'll interview Jerry. And thank you, Jerry, for being here.
Oh, I'm thrilled and delighted, and happy if I can answer your questions. We'll see. Yeah, hydration is obviously really a critical issue, and some of our work on water speaks to that issue. So anyway, I'm sure that will come up in our conversation, but I'll let you be the leader and start with your questions.
Well, I would really love this to be quite organic. There's so much information that you bring forth. You have a couple amazing TED Talks that people can listen to if they want to hear a little bit more. You've structured them really well. What I would really like to do in this podcast is to bring it a little bit further than just human hydration and the possibilities of human hydration to what this could potentially do to help hydrate the earth and the animals, and possibly bring a little bit of information in around your new book on weather and how that impacts our ability to hydrate. So can you start just telling a little bit about your history, Jerry, and how this came about at the University of Washington, the discovery of easy water and what easy water means?
Okay. Well, it all started 20 or 25 years ago, and we were studying mussels. That was my original subject. We were studying how muscles contract. In other words, the molecular mechanism by which your muscles and my muscles and everybody else's muscles contract. And there was a theory, there still is a theory, put forth by a famous Nobel laureate, Sir Andrew Huxley. And Sir Andrew was a sort of scientist among scientists. He, with the name Huxley, he came from the famous Huxley family. So he starts with that distinction. He also won a Nobel Prize, and he was president of the Royal Society and master of Trinity College, Cambridge. And when he walked into the room, there was a hush. This is the great man has walked in, and everyone proceeds in silence. He was an awesome figure. The problem is that his theory didn't match the evidence, and we had quite a bit of evidence that simply didn't conform to the predictions of his theory, and we pressed on for years. And I came to learn about the process of doing science, that revolutionary ideas, of which we had some. There's a real obstacle because it's easier for someone in the field. It's easier to, you might say, kowtow to this great man, and rather than support a revolutionary. And it has to do with practicalities. A lot of it has to do with putting bread on the table, because you need to get grants, and it's easy to get grants if you pay homage to the great people in the field, rather than to the revolutionaries. It's difficult to get the grants, and the grants really matter because you can't do any science without money, and so you need the grants. Anyway, that sort of background. And one of the issues that I've been thinking about is the theory put forth by Sir Andrew Huxley. It implicitly presumed that the muscle proteins were operating in a vacuum. In fact, they operate in water. you know, and if you remove the water from the occasion from the equation, you're missing something that could be important. And I've been sort of scratching my head on that. That's why I, you know, have lost a lot of hair. Uh, Scratching my and thinking about that issue. And one day, I was driving back from the airport, picking up a scientist, a Hungarian scientist who was to be working in my laboratory, and we started a conversation. And we didn't get more than a few miles before he said to me, "You know, there's," in his Hungarian accent, you know, there's a conference in Hungary, and you should go." I said, "Well, tell me about it." He said, "Well, the conference is to honor the memory of a famous biophysicist." And this biophysicist had interests in water and muscle. And there's already a bunch of people going to the conference to contribute on water, but there's nobody on muscle. And 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 this famous Hungarian scientist was deeply involved in muscle. So why don't you go and make a presentation? Okay. So I said, I'll go. So I went to Hungary, and I presented my work on muscle contraction. And I can't remember if that was well received or not well received, but I don't really remember too much. But then came the presentations on water. And I had no background, no experience. And I listened to one guy who actually had been very famous, but I didn't know him. A guy named Gilbert Ling, who presented on water. And Gilbert Ling was a scientist chosen among many young scientists from China to come to the U.S. to study. They looked all around China, and they picked 3 people. This was 1948, the first cohort of people to come to the U.S. from China to study. And they picked a physicist, and they picked a chemist and a biologist. And Gilbert was the biologist. And the physicist, a guy named C.N. Yang, went on to win a Nobel Prize. And he actually became equally or maybe even more famous throughout China when, at age almost 90, he married his translator, who was in her early 30s. And there was also some rumor that she might be pregnant. So that got all around China. But anyway, he was a Nobel laureate. And a colleague of mine told me that the chemist who came was also a Nobel laureate. And Gilbert Ling was the biologist. And I learned, since I began hearing about what he had done, that he deserves at least 2 Nobel Prizes, or deserved. He died a few years ago at the age approaching 100. So I listened to Gilbert Ling, and he said, water is really important in biology. And the water that's inside your cells, inside your body, it's not like ordinary liquid water. He said it's structured. So, what do you mean structured? Well, structured, it means it has structure to it. And he said, you can think of the water molecule as a dipole, like a little bean, with a positive charge at one end and a negative charge at the other end. And with those 2 charges separated, you can imagine that the water molecules would stack upon one another and line up that way. And so he said, in biology, that's the way the water is. So for me, it was kind of a shock. But Gilbert presented ample evidence that indeed that was the case. Years and years of experimental observations that fit, and then compounded by his own presentation, were presentations, or complementing, I should say, presentations of other scientists. And there were perhaps a dozen of them who came and independently did research on water and concluded exactly the same as Gilbert Ling. Well, some nuances of difference, but basically that the water was structured. I was awestruck. I couldn't believe what I was hearing, because the implication of all this was that if these guys are right, especially Gilbert Ling, then all of biology was wrong, because we think of water in biology as like water in a glass. And but these folks were saying, no, that's not true. The water in biology is different, and so it was really important. Anyway, I was astonished in hearing all this, and I rather didn't trust myself. So I came back to Seattle, and I got one of Gilbert Ling's multiple books, and I gave it to some of my students and postdocs. I said, have a look at this and let me know what you think. I was curious whether their thoughts were similar to my thoughts, but they didn't trust my thoughts. And they all came back with essentially the same response. If this guy is right, all of biology is wrong. It needs to start from the ground up. And it looks like, he has quite a bit of evidence in support. So the first thing I did, we were studying for quite a few years about muscles and muscle contraction. And I was kind of put myself in the category as, in search of a fundamental truth. I'm not a guy who jumps on the bandwagon. I don't know why, but I really want to find fundamental truth from the ground up. And so I thought step one in doing this, because I thought Gilbert Ling had found ground truth, and later we found some substantial differences. Essentially, the general idea about structure was correct, but I'll tell you if you ask me about some nuances which I think are really important. And so I decided to write a book to describe Gilbert Ling's ideas in such a way that people could actually understand what he's talking about, because his books are virtually impenetrable for people who don't have a serious background in physical chemistry and in various nuances of physical chemistry. It really, they're challenging. Knowing Gilbert, I know how he operated. He would sit down at the typewriter or later at the word processor, and he'd bat out something, and he'd ship it off to the publisher. That's it. And the word editing, it was not in his lexicon. Maybe the word doesn't exist in Chinese. I'm not sure. But Gilbert could have made it more accessible if he had the desire. But I think he was the kind of guy who thought that everybody was as brilliant as he is, and they would understand whatever he spouted out. And that was not the case. So I wrote a book. It's called Cells, Gels, and the Engines of Life. And the purpose of the book, at least the first half of the book, was to present Gilbert Ling's ideas, and maybe in somewhat simplified form, but in a form that was accessible to people who are open to thinking alternative views, different from the conventional point of views, but it's supported by evidence. And I'm not sure if I succeeded or didn't succeed, because the reviews were mixed. Some of the reviews said, "Oh, this is just more of Gilbert Ling, and we know that Gilbert Ling is a crackpot, so please don't bother even looking at this book." And at the other side, at the other end of the spectrum, was a review from a well-known cell biologist from Harvard University, and of course, if it's Harvard, you got to take it seriously. He said, "This is a 304-page preface to the future of cell biology," and that one had more appeal. Anyway, that's how we got started, and immediately after that, we started doing experiments. I, quote, borrowed some of the money that we had from the National Institutes of Health to study muscle, and I kind of shifted it somewhat to begin studies on water. And those studies have proved, I think, really exciting, useful, whatever. So that's, anyway, if that answers your question. I'm sorry to run on and on, but that's how we got started.
Amazing background, important for people to know. It was an interesting conversation that Paul and I had before we came on to interview you about the skepticism that sometimes we get as a kickback from, or a pushback from, the science community. And there's one of them there in, Ling's work. But also you've taken it further. And now that you have discovered the fourth phase of water, how's that shaping up in the science community? Because we do know that science isn't necessarily science anymore, not in all communities. And there's a lot of funding that has other interests. Let's just
funding is a real challenge. I must tell you. The way the system works. There are two aspects to your question. One is the funding, and the other is the reaction of the community. So I'm not sure which one to address first. Maybe the reaction of the community, because that came first. And then if I forget, please remind me about the second aspect of your question. There has been pushback, and the pushback starts with actually a colleague of mine from my own university, and we had multiple meetings. This guy is in the chemistry department, and he was curious about a lot of things, and we sat and we discussed, and he would ask me a question, and I would come up with the answer, and I felt that he really didn't have so much interest in hearing my answer, but more in demonstrating how smart he was, and how he knew everything about everything. So I heard nothing from him for a few years. And then 2 years later, there were a couple of manuscripts that appeared, major manuscripts, great length, suggesting essentially that our interpretation was completely wrong. And there have been 5 or 6 other responses, all from people in the community who have interest in water, who have studied water. My response is, I did respond to that, the first couple of papers. I haven't responded afterward because most of the critical comments didn't make sense to me, and so they dealt with, just to say, in order for this kind of water, easy water, fourth phase water, structured water to build, you need some kind of material, surface of the material. It builds from the surface, and we've looked at dozens and dozens of different surfaces that have the capacity to build this water, and essentially all of the critical comments dealt with one surface, and we've dealt with so many with completely different properties. Even we immerse magnets in water, and we found that next to the North and South poles, we get this kind of fourth phase or exclusion zone water, and that sort of observation simply goes beyond the kind of criticism that has been waged. So I've known that there's always going to be criticism. If you pose something that goes against the establishment point of view, there will always be people who respond. And I think it was Albert St. Georgi who said, the famous Nobel laureate, the father of modern biochemistry, who said it was only when the response to an idea of his was polarized, some strongly against and some strongly in favor, that he knew he was onto something important, because if it was not important, you won't get any responses from the people who have a stake in the prevailing paradigm. And so yes, we have gotten negative responses, and I actually appreciate critical comments, and I think about them, and usually what happens is it makes me think some more. But the sense that these critical comments are, they don't seriously compromise the ideas that we've put forth. And so on the positive side, it's just amazing how so many people from so many different fields have taken up what we found and have flown with the ideas. And that involves not just hydration, but so many areas beyond hydration, uh, uh, like well, cancer is is one idea. How to build Olympic ice skating rinks so that they're pretty much free of friction. To how the ancient Romans kept cool in the hot summer. Areas throughout all of science and nature and technology. And it has happened over the last 3 or 4 years. I started listing because one of my students told me I should list the number of different applications of this fourth phase water that are serious applications, and the number totals. I started listing them because it seemed like an interesting thing to do, and the number totals roughly 80 right now. So it's really taken off, and I think one of the reasons it's taken off in different areas is that the people working in these areas, they don't really care whether the fourth phase water is right or the prevailing idea, if there is a prevailing idea, is right, because they're interested in something useful, something that helps them. They have no predisposed judgment against, and it's really taken off. So it's taken off to the extent that I'm doing many interviews like this one. Not like this one exactly, but there are many interviews, and a lot of people are seriously interested. And I guess to finally answer this aspect of your question, one of the reasons is that we found that this kind of water actually contains energy. And if you ask me, I can, a subsequent question, I will tell you about it. It contains energy, and energy is useful wherever there's water. There's energy, and this has application or implication in so many different areas. The fact that there is energy that's stored in the water, or in this kind of water. So okay, so that's the first part of your question.
Jerry, before you answer the next one, can you just give our listeners a little bit of an idea what is easy water?
Yes.
If they don't know what easy water is. So we're just going to kind of get back to that.
Yes, thank you. Okay. Yeah, and maybe it's a kind of structured water, but the structure is different from what Gilbert Ling suggested. And maybe it's best if I explain it by telling you the story of how we began studying it, what we found. I think that's probably the best way. So, Gilbert Ling's idea is that the water molecules are ordered. And when you have order of molecules like that, it's a crystal. It's a kind of crystal. You might call it a liquid crystal. And crystals, as they form, exclude particles because they're pure. And in order to attain purity, if you let's say you start with water, and the water forms ice, which is a crystal, the water will get rid of the impurities. Otherwise, the ice crystal won't be pure, and ice crystals are pure. So the kind of structure that Gilbert was talking about would exclude molecules and particles. So we started looking experimentally for some experimental setup where we could see that water is excluding particles, and we found it right away. We took a gel and we put the gel in water, and we added particles to the water. The particles were little spheres called microspheres that widely used, nothing exotic. And we looked under the microscope, and we could see right next to the gel in the water we could see these microspheres were progressively excluded from the region of the surface of the gel on outward, and it kept growing up to, we would see initially we could see up to a few hundred micrometers. That's a fraction of a millimeter, a substantial fraction, which you could almost see with your naked eye. You could see with your naked eye, and so we thought, okay, so this is what Gilbert Ling is talking about. And at first we thought, well, he's right. We could see it right there. We could see this kind of exclusion. And that's why someone suggested to us that we call it exclusion zone, because it was a zone that excluded, or EZ for exclusion zone, which is sort of easy to remember. It doesn't work in Europe where it's EZ, but it's easy. So, but then we began studying this particular zone, and we found that all of the properties that we investigated, they were all different from liquid water. And that's why we began calling it fourth phase water, because it was water of some sort, and it had properties that were not the same as any of the known phases of water, particularly liquid water. So that's the first. So this is a kind of water that is organized and structured. We know that it's structured because of its physical chemical properties, particularly optical properties. And then the maybe the most interesting, well, one of the most interesting features of this was that it was not neutral. Ordinary water, liquid water, is neutral, but we stuck electrodes, tiny micro electrodes, parenthesis, invented by the same Gilbert Ling, close parenthesis, for which he should have gotten a Nobel Prize, because others using that technology have gotten Nobel Prizes, but not him. He was too controversial. So anyway, we stuck these electrodes in the EZ, or in the fourth phase, and lo and behold, it's not neutral. It's typically negatively charged. Now, and we repeated this again and again, and we're still repeating it again and again, and we always find, we find consistently the same kind of result. There's
so the same charge as Mother Earth.
The same charge as Mother Earth, right? Mm-hmm. And well, I don't want to digress too much, but there is water that's contained in Mother Earth, and contained deeply down in the mantle. Nobody knows exactly what kind of water that is, but this so-called primary water is said to have a volume that is something like 3 or 4 times the volume of all the water on the surface of the Earth. So, it's possible that the negativity of the Earth, which is something that took me by surprise, because I'd studied electrical engineering to start with, and nobody ever even hinted that, no professor even hinted that the Earth might be negatively charged. It was always zero. It was ground, so I was taken aback when I first heard about it, and then looked into the Earth's negative charge. And I think that the Earth's negative charge is critically important. It's a digression. I'm happy to talk about it, but let me finish answering the question, if I could remember where we were in. Oh yeah, so we stick the electrode and we measure negative charge. However, it started with water, which is neutral, and you got a zone which is negatively charged. Therefore, there's got to be a zone that's positively charged, because you can't create positive charge from neutral. What you can do is you can separate charge, get negative somewhere and positive somewhere else. And we found right after that the positive charge is contained just beyond the negatively charged exclusion zone. So you have negative, and next to the negative is positive. And if you have negative and positive, you have a battery. And so what we discovered basically is that there's energy that's contained in this battery. And we actually tested to see that. We stuck one electrode in the negative and one electrode in the positive. And we could obtain current enough to light an LED, light emitting diode. You know, we could actually see the diode glowing brightly. So there's no doubt, you know, we have proof of principle that this kind of energy that is created by the separation of charge is useful. And it turns out that it's useful in many, many different realms. So that's another feature of the whole fourth phase business, is that it's kind of like a battery with electrical energy. One more point: in order to get electrical energy, I mean, you know from your cell phone that if you don't plug it in at night, it won't work the next morning. And batteries need to be charged, and this battery needs to be charged as well. So how do you get this buildup of negative EZ and positive charge beyond? How do you get this battery? How do you get to charge it? And it turns out the answer is it comes from infrared light. You know, and it was found by a student who was shining a lamp and found that where the lamp was illuminating the region of EZ, it just grew like crazy. And he turned it off and it returned back to its original. And so we did serious experiments, and we found that it was, you know, because the light that he used contained many different wavelengths. And so we investigated each one of those wavelengths independently, and it turned out that infrared was by far, by 1,000 times more powerful than any of the other wavelengths that we studied. And infrared is all around us. If you were to turn off all the lights and in the room you're in, so you couldn't see anything, and the camera on your cell phone couldn't see anything. If you had an infrared camera, that is a camera similar to one you might have, but the sensor is not sensitive to visible light, but infrared light. If you got one of those cameras, you'd be able to see everything despite all the lights turned off and nothing visible to the naked eye. And that's why the military uses infrared goggles or cameras and whatever to detect what's around them at nighttime. So everything is generating infrared light, not just the toaster or the electric oven, but everything to some extent, you know, and it's energizing this battery. And so as long as you've got infrared energy coming in your case, you know, you have it coming in from outside, but you're also metabolizing, which generates heat, which also then produces infrared energy, because heat and infrared are not exactly identical, but close to it. So you're getting infrared energy from outside and inside, and therefore this is what powers the EZ buildup inside your body. But it's also outside your body because there's infrared there. So if you have the proper situation, which generally involves a hydrophilic surface, water-loving surface next to water, you'll always get EZ buildup. So that means that EZ is everywhere. It's not only inside the body, but it's outside the body too, throughout agriculture and you name it, rivers, clouds, what have you. Okay, so I've given you a background. You asked me the question, what is EZ water? And I hope I kind of made a little bit clear what is EZ water. If not, please ask me. I'll try harder next time.
Okay, so Jerry, the implications for people who are concerned about their health and cellular hydration, proper cellular hydration is obviously they want to make sure that you know, they've got EZ water in their cells, and it occurs to me that, or actually the question occurs to me. It sounds like the process by which EZ water is made is internal. Our cells have evolved in such a way that they can interact with infrared energy to produce these exclusion zones, which are complemented by zones of positive charge. And together, these essentially batteries can cause work to happen. You mentioned in your TED talk the folding of proteins, for instance. So the process happens at the cellular level. So what is the advantage, if there is an advantage, to actually introducing structured water from the outside instead of just trusting that any old water you put into your body is going to end up structured thanks to this mechanism within the cell?
Sometimes, we would hope that the cell is filled with easy water, because easy water is necessary for essentially everything the cell does. If it's a muscle cell, you need the easy water to start with to facilitate the contraction. If it's a nerve cell, you need the easy water to facilitate the information transmission along the nerve. If it's a secretory cell, you need easy water in order for the secretion of hormones to happen. So you need it. Unfortunately, our cells don't always have a full complement of easy water. There can be pathologies or dysfunctions that develop, and in such cases, help can be obtained from external means that build up the easy water. So, I mean, a good example is cancer cells, and there is a pretty clear indication that cancer cells don't have a whole lot of easy water. That comes from direct studies of the kind of water in the cancer cells, and it comes more indirectly, but more conclusively, I think, from measurements of the electrical potential of those cells. So if I may digress for 1 minute, the electrical potential of cells is something that's been studied for 60, 70 years, made possible, by the way, by these electrodes invented by Gilbert Ling, because you can stick them in a cell and measure the potential difference from inside to outside. And then you pull the electrode out and the cell is not dead. It actually is okay. And typically it amounts to between 50 and 100 millivolts negative. And the question is why the cell is negative. And it's almost universally, but incorrectly, I believe, thought that the reason that the cell has negative electrical potential has to do with membrane. What's the right word for it? I hesitate to use the word gadgetry because it sounds dismissive, but it has to do with pumps and channels in the membrane, and these pumps pump ions inside the cell, outside the cell, and the idea is that more negative ions are pumped inside the cell than positive ions, so the cell is negative. I've argued against that idea now in my various books and in a paper that I wrote on the subject, and I think that idea is completely erroneous. And I'll tell you what I think is the reason the cell is negatively charged, because it's relevant to what we were talking about in a moment. But there are at least a half dozen different reasons to draw that conclusion. And one of them is, the cell is, from a simple point of view, is a gel that's surrounded by a membrane. And the question is, does the electrical potential come from some properties of the gel or from the membrane, as almost everybody believes? If you look at gels without membranes, just ordinary gels, and you stick the same electrode in, you get the same negative electrical potential. So, it's hard to argue that it has something to do with the gadgetry in the membrane if you can get the same electrical potential just from the gel itself. And there are other reasons, but I don't want to digress too much. So if not the pumps and the channels, then what's the reason for the negative electrical potential? Well, I think it's very simple. It's got easy water. Easy water is negatively charged. Therefore, you have negative electrical potential. it's not complicated. If you have a sack full of negative charges, the inside of the sack will be negative. So the reason I'm talking about that, it's a digression, but a relevant digression. And the reason I'm talking about it is I mentioned that cancer cells have a very low electrical potential. If I'm right about the reason for the for the negative electrical potential, it means the cancer cells don't have much easy water, see, and therefore they can't function, or they can't function the way ordinary cells would function, because you need this easy water for function. And it also it also has to do with division. It was found like 50 years ago that for cells to divide, what has to happen is the electrical potential has to go from its normal value of 50 to 100 millivolts down to low electrical potential, like near zero, and stay that way for some length of time. Then the cell gets a signal, oh, okay, it's time to divide. Well, cancer cells sit at that low electrical potential indefinitely. And so cancer cell gets the message, oh, got to divide. And it keeps dividing and keeps dividing. So those are some examples of pathological cells, or seriously pathological cells. And the reason for the pathology, I believe, is a dearth of easy water. You must have the easy water to function properly. And that leads to a potential reversal, not just cancer cells, but of all cells. The cells need to have the easy water. Essentially, they need to be hydrated, right? That is hydration. Cellular hydration is the buildup of easy water, and all the cells need to have hydration in order to function properly, full hydration. So I'm sorry, I've gone on a sort of loop and maybe on a tangent, but I wanted to talk about that. I hope that gets at your question. And
yeah, well, you seem to be arguing against the conventional mechanism of ATP production, the ion channels and all the rest of it. Is that right? Are you arguing that cellular energy is produced by easy water as opposed to that potential difference between the inside and the outside of the cell that ion channels capitalize on?
Well, yeah, well, let me put it this way. This is a source of energy for the cell, and usually if in nature has a source of energy, it uses that energy, and we do have one example of a situation, and I think important one, where that energy is definitively used by the mechanism we're talking about. If you ask me about it, I'll tell you, but I don't want to digress too much. I have a tendency, to go on the tree branches off to a limb and another limb and another branch, and I forget where I was. I forget the major limb again. So
I assume you're referring to photosynthesis?
Well, no, but that is
No?
a good. So please ask me that first.
Okay.
Yeah, photosynthesis, absolutely. Yeah. So the energy in the cell, the energy is a bit different, because when you think of the cell itself, it's full of negative charge if it's got EZ, and those negative charges, what they want to do is get as far away as possible from each other, right? Because you put negative charges near each other, they hate it. They want to get away, and that's potential energy, and that's the energy I believe that's used to propel various processes. One of which, if you ask me, I'll tell you. So that's the first thing. The second thing is about ATP. So now everybody knows that ATP is a source of energy, the high energy phosphate bond. And we're suggesting that there is another source, and we don't know, the source that we're talking about. We don't know if it's 1% of the energy and the other 99% is ATP, or there's another possibility. And this possibility was raised by Gilbert Ling, and I feel obliged to mention it because he might be right. And Gilbert Ling talks about, it's still, I think last I looked, his website, gilbertling.org, still exists. He passed a couple of years ago, but the website is somehow maintained. And he brings up the idea of the high energy phosphate bond of ATP, which everybody believes. So that was discovered by a group of chemists, was it maybe 80 years ago? And what's not known or realized by people is that there was a challenge to that. And the challenge came a year or two later by another prominent physical chemical group. And they said, the first guy screwed up. They made a simple arithmetic error. There is no such thing as a high energy phosphate bond. Now, Gilbert Ling's point of view maybe is more extreme than mine. He does point out that, it might be possible, and it looks likely, that there is no such thing as high energy phosphate bond in ATP. I take the point that it's not clear, that it needs to be pursued. The question needs to be answered. If you've got two groups, two prominent groups, that one is arguing yes, the other is arguing no, it needs to be followed up to see which one is right, because the challengers might be right or the challengers might be wrong. It needs to be followed up. It's desperately important that somebody follow up. Now, I don't know what the results of this follow-up might be, but there is a possibility that the whole idea is bogus. That the idea of a high energy phosphate bond in ATP is completely wrong. And so if that's true, if it's a big if it's true, then you got to ask the question, well, if it's not ATP, high energy phosphate bond, what is it? Well, we propose an alternative. And as of today, we don't know if this alternative is presumably it's used to some extent because nature, if nature has an energy source, it's going to use it. It's not going to abandon it. We don't know whether this is the entire source of energy for the cell or 1% of it or what. And so this needs follow-up, but I had to mention. Now, if I may go on to your point about photosynthesis, because that idea tickles me. So we all know that, plants thrive from light. They get their energy from light. I'm suggesting that the energy for buildup of fourth phase is light. And so what we've discovered is that what light does is to separate charge in terms of EZ. So you've got negative EZ and positive charges beyond. Well, that's similar to the first step of photosynthesis. What light does is it breaks up the water molecules into plus and minus. So there's a kind of similarity. And I've always thought that what we discovered is a kind of generic form of photosynthesis, of the first step in photosynthesis. But nature, of course, does it the best way possible. And so nature exploits this kind of mechanism that I think that we've identified, and it does it in the best possible way, the most effective way or most efficient way. And that's why the first step of photosynthesis is considered to be 100% efficient. However, the photosynthesis people have never answered a fundamental question. How is it that light can separate charges, the water charges, into OH minus and H plus? Because I learned in middle school that if you got negative and you got positive, they don't want to separate, they want to stick together. So, how is it? Well, I think we have an answer to that question because what we've been able to find, which I have not yet talked about in our discussion, is the structure of the EZ. So it turns out it's a sheet structure. It's a series of sheets, molecular sheets that build from the physical surface next to the water that I was talking about. You get the first sheet, and the first sheet acts as the template for the buildup of the second sheet, and so on. Sheets, sheets. And each sheet is a honeycomb. It's got hexagons. It's built of hexagons, which are common in nature. And those hexagons are really small. Now, this is a negatively charged structure. And on the just beyond that, you've got all those positive charges. They want desperately to enter into this negatively charged matrix. The problem is that they can't, because when you have a free proton, it latches onto water, giving you a hydronium ion. This is well known in chemistry. So sitting beyond the EZ are all these positive charges, but they're hydronium ions, and the hydronium ion is simply too big to enter into these hexagons. So it's kept apart. It's physically kept apart because it can't physically enter. And so you have the plus and minus charges that are effectively indefinitely separated. And that's what the photosynthesis people have not yet addressed, the idea of how the separated plus and minus, first step of photosynthesis, how that can physically be. And I think in what we found in this generic, I would venture to say this generic first step of photosynthesis, we know, or at least we think we know. we think we know a lot of things that may turn out to be wrong. We're not omniscient, but it's the best we have. So anyway, I hope that answers your question.
Well, that's very interesting. Go ahead, Tammy.
Oh, our listeners are really opening up their mind with this podcast. So thank you, Jerry. So maybe we can, a couple things, because we're coming to an end here. Maybe you can talk a little bit about the implication of easy water. So some of the things that you say that builds easy water is just first putting in the water. We need to be drinking water. We need to stay hydrated, and maybe not all water is created equal. The other thing, which gives complete reverence to what I've studied, I have a master's in plant-based raw nutrition mostly, that vegetables know exactly what to do. And fruit, the water in vegetables and fruit know exactly what to do, that negative ionic charge of that water. And when I've studied at many wellness centers, when people are concentrating on drinking a lot of easy water from vegetable juices and eating a lot more raw food that has the exact molecular structure to know how to do its work in the body, when they're tested 3 months later with the phase angle test, the tests show they're much more hydrated. And this is important. This is important to know, because we know that cancer can't breed in a nice, easy water structured body. Then you had also mentioned putting in the water, considering drinking green juices, grounding, getting that negative ionic exchange from the earth, and infrared saunas, and of course, being out in the sun. So these are all doable things for people to be able to, encapsulate that and their health. But I'm wondering about how the implications of really understanding easy water can make a difference for the animals, our animals, and maybe even the earth. How can we possibly be able to provide water for people where there is very little water? I'm quite curious about that.
Wow, you're going beyond my pay grade. Yeah. Well, I'm not sure how to answer that question. I began talking about the so-called primary water that sits beneath the earth, and the question is, one question may be how we can tap that water to complement the water that we have on the earth. And I have been thinking about that, and I hope this doesn't go into a digression, but I'll say it anyway. When you think about a volcano, for example, there was a volcanic eruption. I forget the name of the volcano this year, and it was said to add 5% of atmospheric moisture. Atmospheric moisture was augmented by 5% as a result of this eruption, which means the eruption contains a lot of water. So what's going on there? Where does the water come from? And presumably it comes from somewhere down below. And it leads to a sort of different question, but it is relevant. Where does the energy come for the volcano? And I've been thinking about that, energy for volcanoes and earthquakes. Where does the energy come from? And some people think, well, the earth was somehow endowed with a kind of energy and still using that energy, but that was a long time ago. It was more than 1,000 years ago. It was more than 1,000,000 years ago, and it was like 6 or 7 billion years ago that the earth was born. And you'd expect that kind of energy would have dissipated by now, but apparently, you need energy to create a volcano. So where does the energy come from? Well, I've been thinking about the possibility that this primary water that exists beneath the earth, that if it forms easy water, it also forms protons, because the two go together, and protons repel each other. They're free and they repel each other, and if they repel each other, they build up a lot of pressure. And I'm thinking that the source of energy could be exactly that the earth may receive infrared energy from the sun, and build up from this energy, build easy water and positive charges, and these may actually build pressure that is the energy that's responsible for the volcanic eruption. And you could argue also the same for earthquakes, because they also need energy. So this is a possibility. And now if the volcanoes and also the earthquakes, if they spew out water, then we therefore can get water somehow from, maybe not in the most convenient way, but we get water from the center of the earth. And so this can add to water on the surface of the earth. So that's one. The second has to do with clouds and such. And is the water stored in the clouds, or is it mostly in the earth? And what makes the difference? And therefore, you were alluding to my next book that's coming out, which actually only partially deals with weather. It deals with other subjects that have to do with phenomena that we witness every day, but we don't really understand them. And I think all of them have to do somehow with water, with energy, with charge, electrical charge that in fact comes from water. So in order to understand weather, you need to understand evaporation. You need to understand how clouds form. And my understanding is that atmospheric scientists have no clue about those two features. So if you want to put more water in the earth, you need to know how much is stored in the clouds, or beyond the clouds, and you need to know how much comes down by way of precipitation. And I guess therefore you need to know something about weather and how it works. And what I've tried to do in this book is to start from first principles of physics and chemistry, principles that are simple, and like plus and minus attract each other, and minus and minus repel each other, starting from principles just like that, and what we've seen in the laboratory, to build a real understanding of weather. And then we can understand how much there is on the earth and how much of it is up in the clouds and the atmosphere, and maybe even beyond. I guess the third is the soil itself, and keeping the soil such that it actually absorbs water in the way that nature had intended. And by putting on these fertilizers and chemicals that treat the earth and in the way that the earth doesn't want to be treated, we lose the capacity for the earth to store the water. And I believe a lot of that water is easy water. And if we lose the capacity, then, you know, the earth is then devoid of this kind of water, and we have a problem. I'd also like to, you know, maybe in closing of this particular question, that a lot of people are not aware. There is a method that's useful for extracting water from the atmosphere to cause clouds and rain. And it's called cloud busters, and it starts from Wilhelm Reich. I'm not sure if you're aware of this, but there's someone who's actually working on this in North Africa. And he's creating so-called green belt from the west to the east of North Africa. A green belt with, you know, trees and plants and whatever, and he makes rain using this apparatus. And of course, it's controversial, but the guy is actually doing it. And it consists of a whole bunch of aluminum tubes held together in parallel, the back end of which is connected to water, and the front end is connected to some point in the sky. And after a period of some days, clouds begin to form at that point, and they release rain. And that's how a green belt is created. So this is a seemingly unnatural way, but a way to create rain, to bring the water from the clouds down to the earth. And it's kind of interesting, I think. So I'm sorry if, you know, I speculated on a whole bunch of different ideas and mechanisms, and I'm not sure, you know, which ones really make serious contributions or not, but I just thought I'd mention them.
Well, you know, the Gaia hypothesis, of course, sees the Earth as an organism. And, you know, it seems like a pretty safe analogy to say that just as, you know, contaminants that we put into our bodies can alter the structure of our cells, which includes the energy exchange that's happening in our cells. In the same way, the contaminants that we're creating on Earth are interfering with those, you know, natural energy exchanges that happen on the planet. I think, you know, what's happening microcosmically is also happening on the macro level. And so I think, you know, appreciating as best we can some of these mechanisms and trying to support their functioning instead of interfering with them is, I think, a real, not just biological imperative, but moral imperative for us as a species.
I couldn't disagree with that one bit. Yeah, but I mean, the Gaia hypothesis, you know, makes a whole lot of sense. It's just the problem is that, you know, if you try to look at physical or molecular mechanisms on how that happens, that's where I think we need to go from the sort of generalized hypothesis. But it makes complete sense. Nature knows the best way to do it, and you know, by interfering with nature, all we're doing is compromising nature's what nature can do so beautifully and so well. So stick to nature, and we'll do well if we do that.
Thank you, Gerald. That's a great segue to ending this podcast. You know, as I wrote in my book, Earth Gut, our gut is a reflection of the earth that we partake in, that we praise or we poison. And we are a million vegan grandmothers, and we hypothesize, but not necessarily just hypothesize, that going vegan helps restore the water that we do have available to us now. Animal agriculture has a huge imprint on our water source and the ability to access clean water from our aquifers. And we have been delighted to have you here, Jerry.
Well, thank you so much, but I have one last question.
Yes.
You can't be a grandmother. You're too young for that. So how is it possible that you're a leader of this group?
I love easy
Lifestyle.
water. I love easy water.
Oh, wow.
And the gift of understanding easy water is when I started studying in the States and understanding how I could heal myself when I got really sick with Crohn's in my early 40s. And you want to talk about the body not being able to stay hydrated when you have a bowel disorder, that's kind of it. Everything runs through you. When I started drinking lots of green juice, drinking wheatgrass, getting rid of as many contaminants as I could from my system, which I didn't really even think I was that poisoned, and started connecting deeper with the earth and my thought forms, because I think it's really important for people to know that we can create dehydration through our thought forms. Stress creates a lot of biochemical problems within our body. So let's just get our easy water on, and youth. That's what we can do if we're really super hydrated with this easy water, right, Jerry? We can begin youthing maybe.
Okay, well, thank you for your response. You didn't answer my question about being a mother or not being a grandmother.
I have 3 grandchildren, 4,
I don't
6,
believe it.
and 9.
I don't
Awesome.
believe it. I don't believe it. Well, congratulations.
I don't have any grandchildren, but I just turned 60, so I'm
No way.
biologically capable of having grandchildren.
Well, you guys are amazing.
This
I
is
would have thought at least 20 years younger for both of you. So congratulations.
Thank you.
Anyway, thanks for the opportunity. And I was really happy to chat with so enlightened couple of people. Thank you.
Thank you, Jerry.
Thank you,
And
Jerry.
I am here today with Dr. Jerry Pollack with the 4th phase of water. We're talking about structured water, and we will have another interview when his new book comes out early in the new year. And Dr. Paul Papin, thank you for your great questions. And we will resume next time we see you. Thank you, Jerry.
Well, thank you. Okay. Bye-bye. So for your health, what builds easy water in your cells? Well, there are a few things we can think about. First of all, drinking water. Well, water is the raw material for building easy water. And so obviously you need to be hydrated in order to function properly. Green juicing. The juice is the inside of the cells of the plant. So you're basically extracting easy water from the plant cells and putting it into your cells. Good strategy. And that's why many integrative medical health professionals suggest that green juicing is the single easiest and best way to maintain your health because of easy, I believe. There are some substances that are known through the millennia to be good for health, and these are just a couple of examples. Turmeric, coconut water. We've studied a half dozen of these experimentally in the laboratory. And we found that putting a certain amount in the water, an amount that corresponds to the amount that might be in your body, builds EZ. It's not published yet, but we're on to it. Sunshine, you go out in the sun, you feel good, you feel healthy, good to be alive. Well, light that you receive builds EZ. And the sauna is perhaps even more effective because the heat means that it's generating infrared light. And infrared light is what builds EZ powerfully and effectively, and that's why you feel good after you come out of the sauna. And finally, grounding, sometimes called earthing, connecting yourself to the ground. Well, you can do this by taking off your shoes and walking on the beach, you see, and you feel good. And why do you feel good? Well, it might be some psychological issue, but you're connecting yourself to the earth. And the earth has been known for a century to be negatively charged. It's a vast repository, practically infinite repository of negative charge. So you soak up this negative charge, which then builds EZ. So are we solar powered? I think we are, like many other living species. And Mother Nature didn't abandon this wonderful mechanism of using light from the sun to give us energy and confer health. And the way this happens, the evidence is showing that this happens through splitting of water, just like the first step of photosynthesis. So we undergo, not just plants, we undergo the first step in photosynthesis. Well, our cells need energy just like cell phones need energy. And some of them that comes from light, not just food, but light. And within limits, the more light we get, the healthier we are. So seek the sun. Thank you. Thank you.